Alright, this is the second lesson in our unit on polygons, and in this lesson we're going to talk about parallelograms. Right? In the previous lesson, in the first lesson, we talked about the angles of polygons, and now we're going to start talking about specific polygons and specific classifications of polygons. If you remember from the table that I gave you during the last lesson, a parallelogram is actually a quadrilateral, or is a type of quadrilateral, and we're going to talk a little bit about what are the properties of these parallelograms. And if you remember, a quadrilateral is a four-sided polygon. Okay, so the first property that we're going to talk about says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. All right, so in this case, JK is congruent to ML, and JM is congruent to KL. Now, they're not. They're JM, JM and KL are not necessarily congruent to JK and ML. That's a special type of parallelogram that we will talk about in a few lessons from now, called a rhombus, okay, or a square, okay. Um, but in parallelograms in general, opposite sides are congruent. Also, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle J is congruent to angle L. Angle K is congruent to angle M. They're opposite each other, go across the middle from each other. Okay? If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Consecutive means they're on the same side. Okay? So in this case it's X and Y. Alright, X and Y are consecutive angles. And if you remember supplementary, if you remember, that means that they are equal to 180 degrees. Okay, they add up to 180 degrees. Alright, and the last property that we're going to mention is that if a parallelogram has one right angle, then it's going to have four right angles. Okay, so and that's a special parallelogram called a rectangle or a square if all the sides have the same length. All right. So if a parallelogram has one right angle, then it has four right angles. Okay, so pause the video and copy these four properties into your notes. All right, we have two theorems that deal with the diagonals of parallelograms. Okay, so the diagonal AC bisects diagonal BD. Okay, if a quadrilateral is a parallelogram, then its diagonals bisect each other. And remember, bisect means it cuts it in half. Okay, so BP from B to P is the same distance as from D to P. All right, because AC bisects the diagonal BP. Likewise, the diagonal BP bisects AC, so from A to P is the same distance as from C to P. All right, and the second theorem says that if a quadrilateral is a parallelogram, then each diagonal bisects, or then each diagonal separates the parallelogram into two congruent triangles. And that's sort of what we had touched on a little bit in the previous lesson when we were talking about uh, calculating the measures of the sums of the interior angles of a polygon. All right, so pause the video and copy these two theorems into your notes as well. All right, our first example says find the value of x. Well, x is right here. Okay, we know that L and j are opposite each other. So we know that they are congruent. So we can just simply say 2x minus 1 is equal to 75. Okay? And solve by adding 1 to both sides. We end up with 2x is equal to 76 divided by 2. 76 divided by 2. If we get our calculator, is equal to 37.5. So x is equal to 37.5. Oops. Wait a minute. No, it's not. I did 75. All right. So let's erase that. All right. 30. Oops. Let's see here. 76 divided by 2 is 38. So x is equal to 38. Yeah. So 76 divided by 2 is 38. So all right. The next example says find the value of y. We know that opposite sides have congruent lengths. So we know y minus 4 is equal to 11. So y minus 4 is equal to 11. We're going to solve just simply by adding 4. Adding 4. All right, so y is equal to 15. Okay? All right, because when you plug in, we know it has to be equal. So 15 minus 4 is 15 minus 4 is equal to 11. Okay? So our value of y is 15. It's important to notice here that the side TS is not equal to 15. Side TS we know is equal to 11 because it's congruent to QR. All right? But the value of y is equal to 15. All right. Here it says find the value of A and B. Well, here we're talking about our diagonals. These are talking about those two theorems that you guys copied into your notes. Okay, remember that the theorem said that the diagonals bisect each other. Okay, so we're talking here about A. All right, so that's this side. A here is congruent to this side, which is 2. So we have A minus 7 is equal to 2. Okay, when we solve that for A, it goes plus 7. So A is equal to 9. The value of A is equal to 9. Likewise, 2B minus 6 is equal to 10. When we go to solve that, add 6 to both sides. 2B is equal to 16 divided by 2. And our value of B is equal to 8. Okay? Our last example, find the value of W and B. All right? Same thing. Same exact thing. If we can do, it doesn't matter, W is first, so we'll do W first. Okay, this is congruent to this, so we say 4W minus 7 is equal to 2W plus 3. All right, so we go to solve. We're going to collect the W's first, so we're going to subtract the 2W from both sides, minus 2W. The 2W's cancel out. We're left with 2w minus 7 is equal to 3. Add 7. 2w is equal to 10 divided by 2. W is equal to 5. All right? If we solve for the b's, 3b plus 1 is equal to 2b plus 5. Okay? Solve. Combine our two b's. Bring the 2b from the right over to the left by subtracting it. We're left with 1b plus 1 is equal to 5. All right? We are going to subtract 1 from both sides. 1 times b is just b. 5 minus 1 is 4. So b is equal to 4. All right? So that should do it for this lesson. We don't have any more examples. And if you have any questions, make sure you ask them. And I'll talk to y'all later on.